we're going to make wavetables. And we're going to make a giant vector that contains the wave information. And we're just going to access the point of memory that we want on the wave, pull that particular part of the wave out, and use it. And that'll be a lot faster than calculating out each wave. So the first thing I'm going to do is set up a way to create wavetables. So we're going to do void generate wavetable. Alright, so we've declared that. We're going to generate wave. Well, it's not just going to be waves, so we're going to generate more things like a frequency table and another exponential table for the ASDR envelopes. But for now, actually, no, we can do without that. So we'll work with waves now, and then I'll tell you what else we're going to add into it. So we're going to generate these tables on the first run around. And what's going to be in here? Well, let me comment this first. So void the first thing we need to do is determine our wave size. So this is going to be how many elements we're going to populate this table with. This is going to be 4 tables. So the wave size, we'll do define. So the waves, darn it. Okay, so the length of this wavetable, we're just going to make not too astronomical. How about 1024? This is sort of an 11-bit length. Nice round number. And we're also going to define how many waves we're going to make. So wave type, size. And we're just going to do 4 waves. There's going to be a sine wave, there's going to be a triangle wave, there's also going to be a square wave, and a saw wave, finally. We'll also we're going to include noise as well. We may not do it this round, we may add that in later. For now, we'll just do tables. So let's go back here. Here it is. So we'll define an integer, I equals 0. This is going to be our index to go through the table as we add stuff. I less than the wave size. And yep, okay. So the first wave is going to be a sine wave. And let's just index 0. I'm going to force it to be an integer. And ooh, did I define these signal bases? Okay, I did keep them. There's some more stuff that I did add that I didn't tell you. So we're going to define a signal base of 3500. It's just a generic term. It's less than 12 bits, but it'll be maximum wave size that we're going to consider. It's just kind of arbitrary. We don't have to worry about it at this moment. So the last time I was touching this, I was messing with a 12-bit DAC. We'll keep the 4096. This go around, we're going to be working with an 8-bit DAC. We're going to extend that later on to 12. But for now, that's okay. And then this LV max, that's a level max. We're going to be using a 8-bit number to do scalings, and by scalings I mean for mixer knobs. They're going to range from 2 to 256. So we'll go back here. So max wave size is going to be the signal base, so we're going to do sig base divide by 2. I'll do 0.0 because we're working with floats in here. Then we're going to do a sine wave. And at this point, we want only one wave to exist in this table. Some manufacturers will do half a wave. Some even go as low as a quarter of a wave just to save memory. But we're going to put a full wave because we have plenty of memory to deal with. We're going to do 2 pi. That's 6.283 times our index I. We're going to put that in parentheses to make sure that multiplies first, which we don't actually have to do in C for this in this scenario, but I'm going to make it explicit just to know we did it. And then you divide it by the wave size. And so that way, between 0 and 2 pi, you have one wave, and we're just going to scale the progression between 0 and 2 pi by the size of the table. So if you're halfway through the table, you're halfway through, the 2 pi within the sine function. So that should be about it. So that's the sine wave. The next thing, so 1i, this next one is going to be a square wave. That'll be really easy. So we're just going to make the positive side, and then when we're halfway through the table, we'll just do the negative side. So, force it to be an integer. It's going to start off as the signal base, divide by 2. Whoops. And then if we're halfway through, then we just do the negative of it. And even though we're doing this at the beginning of the code, it'll calculate this stuff pretty quickly, and you won't even notice it's happening. All right, the next one that we're going to do, this is going to be the triangle wave. So this is made a little bit differently. We're going to go up, and then at a certain point, we're going to go back down. So in order to do that, we'll force it again to be an int. Whoops. All right, and what we'll actually do is we'll do 2 times I times the signal base, and then divide that by the wave size. And since we start at 0, we're going to offset this by the signal base, by half the signal base. So we start halfway down, then halfway through the table we'll be at the top of the wave, of the total wave height, and then we're going to do the opposite when we come back. So that's that. So if we're halfway through, then we'll do this but the other direction. So to do this, signal base divide by 2. So to do this, since we're at the top of the wave height, we're going to begin with the signal base, and then we're going to subtract us going down. And we don't want to end at 0, we want to end at the bottom. So we're going to also put this offset here. And that should be the triangle wave. We'll check this later when the MCU calculates it, and we'll pull what it calculated out of memory and plot it. And we'll be able to see if we got this right. And the last thing is the saw wave. The saw wave is one of the easier ones. So this is number 4. Force it to be an int as well. We'll do I times sig base, divide by the wave size. Oops. Yep, and then offset that. All right, so just like the triangle wave, instead of counting up by a slope of 2, we're just counting up by a slope of 1. And that should be it for those waves. The next thing we can do is also the frequency table. Since I'm going to be using a piano to control, whoops, I'm mid-thought, hold on. Since I'm going to be using a piano to control the synthesizer, I have to generate the frequencies for each key. I don't have to, but I will. So we're also going to generate frequencies. And yep, okay. So we're going to use I again. We're just going to start at 0. And we're going to make this go through 89 different iterations. So in this case, freak list. And these are actually going to be 32-bit integers. So in the MSB 432, you do uint30__t, uint32_t. Yep. And then the equation for the Western music scale that's used is 440. So that's middle C, I think. Middle A. I forgot. Anyways, then it's 2 raised to fraction power. So you can go ahead and do pow, put in 2 there, and then the power that you raise it to is kind of funky. It'll be I minus 49 because the 440 hertz is at 49. And then you're going to divide it by 12. And that should be the frequency list finished. Ah, no. We have one more. Like I said, the lowest frequency will be 0, so. All right, cool. So that's the base waveforms and the frequency list. So let's go ahead and check those out. Oh, wait, no, I can't do that now. I have to put in these variables, so let's go up here. Ah, finished. Okay. So let's see what these waves look like. So we got our almost synthesizer here. I'm just going to plug this up. This is going to be quite a useless view, but thought it'd be exciting for you. All right, and then we're going to go back. All right, wasn't that fun? Let's go ahead and build it, and we'll commit it to the device. It's uploading. And then we're going to run it. And then I'm going to just pause it and pull the values from those tables, and then we'll see and make sure they turned out right. All right, cool. Let's run it. All right, it's running. Should be done. Pause it. And we'll go ahead up here. I already added frequency list and wavetable up here and the expressions list. And so now that it's paused, it can pull information from it. So this one should be a sine wave. So let's go ahead and plot that. And change the scaling on the axes here. Yep, that looks like a sine wave, so we generated that correctly. Let's go on next to the triangle wave. We'll do the same thing. Check and make sure. Oh, nope, sorry, square wave. Looks like a square wave. Now onto the triangle wave. Something screwed up there. Let's go ahead and verify the saw wave, and then we'll come back to that one. Yep, saw wave's fine. So let's go back to this, see what's up. Let's try a different approach. All right, run it. All right, it's generated the tables. Let's try this one more time. Then after this, we can finally, oh, there we go. Yep. Okay, so there's a triangle wave. So we verified them all. They all work fine. So the next thing to do is to set up the oscillators.